Hello everyone, the chapter which we are discussing is chapter Machines of class 10 and the topic which we are going to discuss today is machines, technical terms and levers. The objective of our today's topic is machines and functions of a simple machine, technical terms related to machines, principle of a machine, levers and principle of levers, class 1 levers, class 2 levers, class 3 levers with their examples and examples of levers in human body. So the first topic is machines and functions of a simple machine. A machine is a device that helps make work easier and faster by accomplishing one or more of the following functions. The functions are like by increasing the magnitude of the force, by changing the point of application of the force, by changing the direction of effort to a convenient direction, or by increasing the speed. If a body is performing even any one of these four functions, it is considered as a simple machine. Let's discuss all of them in detail. The first point is a body acts as a machine if it gives us increase in magnitude of force. Here we have example of a jack screw. A jack screw is used to lift a car, right? And we cannot lift the car by ourselves. We apply force on the jack, manual force on the jack at this point, and in result it lifts the car. We cannot lift that car by our own with our hands. This means this jack screw has done something with our force. It has increased the magnitude of force which was able to lift this car up. So this jack screw is considered as a simple machine as it is giving us a increase in magnitude of force. The second function is by changing the point of application of force. To move the rear wheel of this bicycle, we apply the force on paddles. This means it has changed the point of application of force. We can easily apply the force on paddles and the bicycle will move. The third is by changing the direction of effort to a convenient direction. If we pull the bucket from well by applying the effort in upward direction, the direction becomes very inconvenient. We have to bend and we have to pull the bucket up. If we use this machine, which is called a simple pulley, here the direction of effort is changed. Now we have to apply the effort in downward direction, which is a very convenient direction. So this pulley is also considered as a simple machine as it is changing the direction of effort to a convenient direction. The fourth is by increasing the speed or to obtain the gain in speed. In case of a scissor, the blades of scissor are very long. On applying effort here just once, due to the long blades, the scissor will cut more amount of cloth. That means we are increasing the speed. This pair of scissors is helping us to increase the speed of cutting. That is why this pair of scissors is also known as a simple machine. So on the basis of all these functions, a machine is a device by which we can either overcome a large resistive force or load at some point by applying a small force as we have done in case of jack, right? At a convenient point and in a desired direction or by which we can obtain gain in speed. We have discussed all four functions performed by machines in this definition. Now the next topic which we have is technical terms related to machine. The first term is load. The resistive or opposing force to be overcome by a machine is called load. In case of example of jack screw, we have to lift the car. So car acts as a load. And we apply some force on the jack screw, that will be our effort. So effort is the force applied on the machine to overcome the load. The next term is mechanical advantage. The ratio of load to effort is called the mechanical advantage of a machine. As load is a force, it has unit Newton. Effort is also a force, it has unit Newton. So Newton will cancel each other and mechanical advantage has no unit. The next technical term is velocity ratio. Its name is specifying its meaning. The ratio of the velocity of effort to the velocity of load is called velocity ratio of a machine. And it has one more definition. Velocity ratio is defined as the ratio of displacement of effort to the displacement of the load. As velocity and velocity has the same units and velocity ratio is a ratio, displacement and displacement has same units and it is a ratio of displacement to displacement. So the units will cancel each other and velocity ratio has no unit. The next technical term is work input. Again, its name is specifying its meaning. The work done on the machine by the effort is called work input. Next is work output. The work done by the machine on the load is called work output. The next term is efficiency. Efficiency of a machine is the ratio of work done on the load by the machine to the work done on the machine by the effort. This means efficiency is the ratio of work output to work input. As it is the ratio of work to work, it also has no units. Next is an idle machine. An idle machine is that in which there is no loss of energy in any manner. Here, the work output is always equal to work input. That is, the efficiency of an idle machine is always 100%. Next is actual machine. In an actual machine, the output energy is always less than input energy because there is always some loss of energy during its operation. This loss of energy happens due to friction between the moving parts of the machine. Next is principle of a machine. According to the principle of a machine, for an idle machine, the output energy is always equal to input energy because there is no loss in case of an idle machine. In practice, idle machines do not exist. There is always some loss in machines due to the friction between the moving parts of the machine or due to some other reasons. Next is relationship between velocity ratio, efficiency and mechanical advantage. Beta, as we all know, efficiency eta is equal to work output upon work input. Work output is load into displacement of load. Work input is effort into displacement of effort. Now, load upon effort we have done. Load upon effort is mechanical advantage. Displacement of effort to displacement of load is velocity ratio, but this is reciprocal of velocity ratio. So we are here writing the reciprocal of velocity ratio. So according to this, the relation between efficiency, mechanical advantage and velocity ratio becomes efficiency is equal to mechanical advantage over velocity ratio. The next topic is levers. A lever is a rigid, straight or bent bar which is capable of turning about a fixed axis. Levers are of three types. Class 1 lever. In class 1 lever, fulcrum is in between load and effort. Then we have class 2 levers. In class 2 levers, load is in between fulcrum and effort always. And then we have class 3 levers. In class 3 levers, effort is in between load and fulcrum always. If we discuss these with the help of these simple diagrams, then this is class 1 lever. The fulcrum is in between effort and load. In this case, load is in between fulcrum and effort. So this is the diagram, general diagram of class 2 lever. In this case, effort is in between load and fulcrum. So this is the general diagram of class 3 levers. Let us now discuss some examples of class 1 levers. A pair of pliers. Here this is the fulcrum of the plier. Here we apply the effort and this is the load. So this is a class 1 lever. A spade turning a soil. This is the fulcrum. This side we have load, this side is effort. So spade turning a soil is an example of class 1 lever. Shears, metal shears, which cut the metal sheets. This is the fulcrum. This is the metal sheet, which is load, and here we apply the effort. So fulcrum is in between effort and load in this case. So this is example of class 1 lever. This seesaw is also example of class 1 lever, and spoon used to open the lid is also an example of class 1 lever. We have some more examples of class 1 levers. A crowbar. In this case, this is the fulcrum. Here we are applying the effort and this is the load. Next example is example of a pair of scissors. This example is similar to the example of shears, which we have already discussed. This is the fixed point fulcrum. This is a piece of cloth. Here we are applying the effort. So this also is an example of class 1 lever. Then a claw hammer. In case of a claw hammer, this is fulcrum. Here we are applying effort. This is the load. So this is example of class 1 lever. And one more, handle of a water pump. This is the point where it is fixed. So it is the fulcrum. Here we are applying the effort and this is the load, that groundwater. So load is this side. Here we have effort. Fulcrum is in between load and effort. So this is an example of class 1 lever. Let us now discuss some examples of class 2 levers. A bottle opener. This is the fulcrum because we fixed the bottle opener here. This bottle lid is the load and here we are applying the effort. So we can say that load is in between fulcrum and effort in this case. That is why this is an example of class 2 levers. A nutcracker. In case of a nutcracker, here we place the nut, which is a load. This is the point where nutcracker is fixed. So this is the fulcrum and here we apply the effort. Load is in between fulcrum and effort. So this is example of class 2 levers. Similarly, a bar used to lift a load. This is the load. Fulcrum at which this rod is fixed and here we apply the effort. So this is an example of class 2 levers again. One more example, a wheelbarrow. Here we carry the load. So this is the load. This is the fulcrum and here we apply the effort. Load is in between fulcrum and effort. So this is an example of class 2 lever. Let us now discuss some examples of class 3 levers. A foot treadle. This is the effort. Here we apply the effort in this case. This side we have the load and this is the fulcrum, a point about which it is fixed. And that is why this is an example of class 3 lever. Sugar tongs as well as ice tongs and fire tongs. These all are the examples of class 3 lever because here we have the load. This point we apply the effort and this point is fulcrum. So effort is in between load and fulcrum. So this is an example of class 3 lever. Similarly, a knife also. Here we apply the effort. Here we apply the effort. This is the fulcrum and this is the load. Here we have the things which we need to cut with the knife. So this is an example of class 3 lever. And a spade lifting a load. We lift the spade from this position. So this is the effort. This becomes the fulcrum and this becomes the load. Effort is in between fulcrum and load. So this is an example of class 3 levers. Next is principle of levers. Here we have a diagram of levers. This is the fulcrum. This is the effort and this is the load. The distance between fulcrum and load is known as load arm and the distance between effort and fulcrum is known as effort arm. According to the principle of levers, load into load arm is equal to effort into effort arm. Let us now discuss the examples of each class of levers as found in the human body. So, the example of class 1 lever in human body is nodding of head. In this case, this becomes the fulcrum about which our head is moving. This is the part where the effort is felt and this is the load. So fulcrum is in between effort and load. So this is an example of class 1 liver in human body. Next is example of class 2 livers in human body. Raising the weight of body on toes is an example of class 2 livers in human body. In this case, load acts vertically downward from the middle of our foot. Toes are the point about which we are able to move our body, and effort is felt by the muscles at the other end, here. So this is an example of class 2 livers in human body, as load is in between effort and fulcrum. Next is an example of class 3 livers in human body. In this case, this is the load to be overcome. Here we are feeling the effort, and this is the fulcrum, the point about which we are moving our hand. So, raising a load by our forearm on our palm is an example of class 3 livers in human body. So, that's all about our today's video. Please read and revise the topics discussed in the video from your books. Thank you so much.